unwrapped. So I think we'll start with these turned all the way down. Should we try the 220?
Yeah.
It says in the instructions it can handle between 100 and 240 volts, so
2 legs of 220.
that seems like it'd be best. But it says on the machine that it's 110 volts. Let's try that first. See what it does. I mean, look at this sticker. Try reading it.
It says refer to manual.
Special considerations. Before using the device, please read the manual and pay attention to the matters requiring special attention in the manual.
The manual doesn't even tell me exactly what I need to put in. I imagine it was in Chinese and it's run through Google Translate. So, got this coil here. It's just a copper coil. This part's wrapped in Kevlar. And the idea here is we run, it's like 30 to 80 hertz, 80,000 hertz, and that will induce voltage in whatever.
That's where you get you.
Yeah. So it's basically like a transformer where this is the main coil, and then we'll have another, piece of metal in here, and that'll be the second coil. But of course, that one will be shorted out, so it'll create a lot of heat. And you can focus the heat very precisely on it. Supposedly, it can get up to 4,000 degrees Fahrenheit, so this ought to be fun if it works. But I need to figure out how to get the water to go through here, and I don't know if this thing has a pump or not. So that's what we're going to find out. Over here we're wiring it in. This is that 10 gauge? Yeah, hopefully that's heavy duty enough. If this thing puts out the full 15 kilowatts, there's no way that'll handle it.
Yeah, we'll have to get bigger wire.
Well, at least it'll be like a fuse. But these are tiny lugs though. You'd expect if it was 15 kilowatts, I think the lugs on our dryer is bigger than that. Need a wrench. That's what you figured. Alright, I'm going to see if I can figure out how to get this water pumped into it. So we got water in. Why are there two? The manual didn't say anything about two water supplies. I got a tube here. I guess I can just splice this into a garden hose. Minimum water pressure 0.12 megapascals. Let's see if it'll come off. Alright. Got a nice big relay there. Is that really all the water is doing in here? Okay, so that's cooling. I mean, you got some pretty heavy duty connections in here. That's all the water's doing. Why is that in a coil around there? It doesn't seem necessary, does it? Oh, I see. That's the oscillator. Transistor switch. That's a pretty heavy duty transformer right there. Those are solid wires. And all the way up that thing. What valve's that? Right.
Here you've got some essential electronics equipment. That is hot glue holding this stuff together. Fantastic.
As long as it's soldered down inside, that's not really a problem.
Unless it gets hot.
This is how we've got the tubing. Looks like the water comes through just fine.
You have to tie a wire tie around there?
Yeah, hold them together. keep them in the bucket.
Like you take this one like this, and this one like this, and then tie them right there. Not too tight. You want to squish them.
There we go. Want to turn that water back on? Yeah. There you go. Yeah.
You might end up taking that off and loosening it up.
Got a bit of a leak over here.
Where?
Right in this fitting. Do you have any of those fuel line clamps we could stick on there? Some clamps here. Is there one tighter? Let's try this one. I think it's smaller. What do you think?
They will work. It takes a little while for them to seat, but they will. We may have to put some sealer in the threads so the water can't crawl through the threads.
Yeah. Do we have any like silicone or something?
Yeah, we got some of that aviation sealant.
Yeah, this should help.
Let's see if that'll work. Kick it on?
Yeah. I seem to have stopped the leaks. At least down to the level that...
Slow that water down too if you want. Yeah, one of them don't want to run very fast, huh?
Just going through a lot of tubing in there.
We'll shut it off there so you don't have any air in it when we...
Okay. So you're just going to go back through anyway. Okay, so there's the water supply. We need some way to empty that bucket. Here's the generator we're going to use to run it. Here's the data plate. You see it's a 20 kilowatt generator with up to 62.7 amps on multiple phases, 3 phase I think. Glowing red hot, but you can't tell if it's in the sunshine. need something smaller, I think.
How much of this do you want me to film? Do you want me to cut then? Not at all?
Definitely getting hot down in there, but not hot enough to melt steel, which is what I needed to do. That's 240 volts we got plumbed in now. What do you think the chances are of that burning up now?
Here, let's see what it is to ground.
Shouldn't be anything in there.
Read.
There's 120, I think.
120? Okay.
Well, it's melting the aluminum, so it does work. So we got 300 amps going through it. Got a lot of voltage. It is going through pretty quick, huh?
That's quite a bit of heat to be able to do that.
What do you think? If we just left it on longer, it'd melt steel?
I don't know.
Got somewhere we can pour the aluminum out. coating, see what happens. Ooh, it's warm. Theoretically, the steel should heat better than the graphite would because it conducts better, but and it's also ferrous. Oh, the zinc's burning? Sure is. Since the zinc's vaporizing off, we know that the temperature is around 1700 degrees Fahrenheit. It's melting them. See any liquid metal down there?
Yeah.
Well, they appear to be welded together at least.
They're welded together.
Well, that one's in half. See it?
Well, you got liquid metal right there.
Yeah, we do.
You do. You got one melded.
That's melting steel. Well, good. It's definitely melting it. Here, let's throw this piece in there too. That's liquid iron. Steel even. Actually, I wonder if it's absorbing any of carbon from the crucible. That would turn it into cast iron, right? Can you see down in there at all?
Yeah.
It is melting it. Melted the nail a little bit even. This iron's melting almost like it's brass or something. Look at that. The nuts are gone. That'll work.